Many Year 13 students drive a car to school. A sample of students' travel times found that it took between 5 and 60 minutes to drive to school, with most people spending 25 minutes. Okay. Now you've got to make a choice about distributions. This is continuous data. It has a definite beginning, definite end, so it's got the two cut-offs, and it tells you the most people, so that is the mode. So our best choice is a triangular distribution. What you need to do now is you need to draw it, and the beginning was 5 minutes, goes up to 60, and the most common was 25. To find how tall the distribution is, the greatest value is B, the least is A, and your height of your distribution is 2 over B minus A. Okay, now we need to find students spending more than 25 minutes. So more than 25 minutes is from the mode upwards. We need to find the area under the curve because we need to find the probability. So this is a triangle and it goes from 25 up to 60. So it goes, spans 35 minutes, and its height is 2 over 55. We're going to go half times the base times the height to find the area of the triangle. Half times 35 times 2 over 55. 35 over 55, or 0.6364 when you work it out on your calculator. So given that it takes a Year 13 student more than 25 minutes to drive to school, what's the probability that it takes them more than 40? So with a question like this, we're only considering the more than 25 minutes part of the distribution. And in the previous question, we found that the area of the large triangle, given that it takes more than 25 minutes, this big triangle has got an area of 0.6364. So we got that. We have to find the probability of them taking more than 40, so between 40 and 60. Now, we use similar triangles. So, triangles stay in proportion. So to go from 25 up to 60 was a height of 2 over 55. To go from 40 to 60, well, that's a distance of 20. 25 to 60 is a difference of 35. So we're looking for 20/35ths of the total height. So 20/35ths of 2/55ths. Total height. When you work that out, you get 0.2078 on your calculator. So the small triangle has got an area of a half times the base, half times 20, times its height, which is 0.02078. When you work that out, you get this area here. Now finally, we need to find the small triangle as a proportion of the large one. So we've got 0.2078 over our large one, and that is our answer. So Year 13 students who live more than 30 minutes drive away get priority parking. What's the probability of the first 10 cars driven by Year 13 students, at most 3, get priority parking? Let's deal with the first part of this. So we need to find out the probability of being more than 30 minutes drive away from school. So what we've got here is we're interested in this small triangle here, 30 up to 60. To find the height of the triangle, well, again, similar triangles. So the highest it goes to is 2 over 55. And that is when you span a distance of 35 minutes. If we're going from 30 up to the very end of the distribution, which is 60, that's a length of 30 minutes. So we need to find 30 35ths of the height. 30 35ths of 2 over 55. On your calculator, you will find it is 0.03117. We now need to take that and we need to use it to find the area under the curve for between 30 up to 60 minutes. So the area is half the base times the height, half the base, which spans a distance of 30, times the height, which is 0.4675. Second part of the question. What is the probability that of the first 10 cars driven by Year 13 students, at most 3 get priority parking? Now this is a binomial situation because we have success or failure, we have a set number of trials, and we now have a probability. So we'll use our graphic calculator. We're going to choose binomial distribution. And we're looking for at most 3. So we're looking at 0, or probability of it being 1, or 2, or 3. So we use BCD. Our data is variable. Our X is 3. Our number of trials is 10, because it was about 10 students. Our probability is 0.2304. Sorry, our probability is 0.4675. 0.4675. When we do that, we find that the probability of at most 3 getting priority parking is 0.2304. Now, in the question, we also had to give an answer about state any assumptions you have made. So, again, you can look at the various conditions, and one of them is that the probability of taking over 30 minutes remains constant for the binomial distribution. And that may not be so because, for everybody, there might be some event like an accident or roadworks or whatever, and that might increase the probability of taking longer.